Hello, everyone. It's very nice to be here. My name is Jean-Pierre Rometo. I'm from the National Institute for Space Research. And what I'm going to talk today about is a large airborne laser scanning data set that we did in the Brazilian Amazon. Before going on, I would like to thank Chris Fisher for the invitation and also the Earth Archive to have me here today for this talk. So that's a very brief outline. I'm going to talk a little bit of tropical forest in general, basically carbon. So why we did this this work. Show some biomass maps, the LiDAR sensor and the scanner procedure we did. So how we process the data bit. This project was called EBA, which stands for the Brazilian Biomass, Amazon Biomass Estimate. And also going to show some products of our work associated basically to forest structure and to carbon accounting. So, okay. So tropical forest, it covers about 40% of the remaining forest in the globe. We are talking about 40% of 4 billion hectares of forest in the globe. It's a very high diverse ecosystem, as we know. 1/4 of the total carbon stocks in land ecosystem in the globe it's associated to tropical systems and tropical forests. But there's a huge uncertainty of this, and to give an idea of that, the Amazon forest biomass maps, for instance, on above ground biomass, it diverged by a factor of 2, basically. So it ranges in literature from 40 to almost 100 petagram of carbon for these estimates. There's also a big threat. So the tropical forests are threatened by both climate change. It's a very strong climatic change in the region lately, and but also being threatened by strong land use and land cover change. Just to have an idea, the loss of forest in the 15 years from 2000 to 2015 is estimated to be around between 5.5 to almost 12 million hectares. And if we see this little figure down there, we have the distribution of the tropical belt, we see where most of the deforestation happened, and part of that was in the Amazon, and specific the Brazilian Amazon. So when we're talking about the variation on estimates of biomass, we see here a suite of biomass maps that derived from a different source of data. We have on the upper left part one of the most extensive data set of inventory in the region, but it was done in the 70s and 80s, and it's called Radam Brazil. It was a federal program that did this huge inventory in the region. And there's another one that is becoming a very important data set as well, which is a national forest inventory, which is the second map below, that we have the forest biomass are becoming extensive in the region. But out of that, we have a lot of points, inventories or research field plots that are associated to the maps that we see on the right. So the maps that we see, that they are derived from different effort, from different research effort. And as you can see, the variation in the biomass estimate is very substantial. And in a sense, this is very important in terms of understanding from forest dynamic to carbon emissions due to deforestation or degradation or fire and thus far. So what we did, we processed, actually with the support from the Amazon Fund, we flew a LiDAR, airborne light laser on the region. We flew about 1,000 transects, each one with 375 hectares. We're talking about only the Brazilian Amazon. You see the whole Amazon in the South American map up there, which actually is the whole northern part of the region. Some of the flights we did twice, about 20% of the flights we flew over the region, and we have some specific directed efforts, but also we use some products that we have here at the National Institute for Space Research to use as mask. For instance, products is a deforestation map that we produce, and we use that as a mask to fly basically over primary or less disturbed forests. We have several flights over secondary forests as well, but we had those maps to randomly distribute the flights. So the flights were randomly distributed using those elements. So here I'm not going to go through much of this, but it's just to give an idea what sort of equipment we used. An important point here is that we use 4 pulses per square meter, which for forest biomass is not bad. And actually, it varied a little bit. We had some place we had 4 times that, and others a little less, but mostly that was the basic the density required. And so we have the flying height was about 600 meters. Trying to have a stable flight, and the provider was Fototerra, which is a Brazilian company which does those sort of surveys. So that's basically the framework for our producing the maps. So we have the ground data for validation and calibration. Then we have the scanning. We used a equation, a biomass equation from Lidar inventories to have the biomass on the specific transects. We use the remote sensing data for extrapolating, looking to the whole region, but also the random forest regression model to extrapolate all that and doing the map. The random forest was fitted to basic 150,000 cells of 200 by 250 meters resolution. So it's a very high dense amount of data. So we did the GeoBase on a PostgreSQL on the basic for the automated biomass calculation and generation of the biomass map. We processed the data with a script that we wrote in Python, and so that's basically how we manage the model data. But we have challenges on that. Part of the challenge is associated to the field plots in terms of size and location and the sort of the inventory data we had. We tried to harmonize that as much as we could. And but also there were some different years that inventories were conducted, and as far the LiDAR data, it was a big amount of information. So that was also processing of that was part of the challenge that we faced. So that's the result. We have what's called, we can say, a new biomass map for the Amazon region. It was even included in the Brazilian National Communication for the Climate Convention. And the very interesting aspect is step forward with that this methodology allow us to provide. It was an uncertainty map. So we have an uncertainty map that varies from 0 to 20, but it's a big higher in a higher biomass region, which is upper to the Guyana shields up there, and but it's a very good uncertainty in terms of calculation, in terms of resolution of the data. And as well, we provide some other information for that. So this huge amount of data, it's helping to understand other process, not only the structure of the forest, but some dynamic as well. So we've been associating the forest structure and the availability of a tree height, for instance, associated to the resource availability. to disturbance in frequency. So if we see on the map here to the upper part and on the right is where we found the highest tree in the Amazon, the tallest tree in the Amazon, which is 80, almost 90 meters tall. To the left of the screen, we see a canopy size frequency distribution across the region. And on that, associated to the disturbance and human modifying forests and not human modifies. And a good thing that is maybe give a little connection to the next thought by Eduardo is that this is a recent disturbed and modified forest. The next, and we using still the sort of understanding the frequency of gaps and the relation of gap frequency and mortality. So bringing the structure a little bit to the dynamic, looking to different vegetation type and regions, sub-regions in the Amazon that allowed us a little also move forward on understanding a little bit how the dynamic, the mortality, and all this process influenced the biomass in the region. All those information is being published, so you can see the data there. This is the last example I would like to give, which is it's associated to the fragmentation of deforestation in the region, and actually how this the fragmentation, deforestation, kind of percolate within the intact old growth forests, leading to loss of biomass in a distance between the deforestation throughout the forest edge. So the LiDAR has allowed to come out with all those sort of very detailed information. And to recall that we're talking a region of about, in this case, they did the work in the whole Amazon region, South American Amazon, but we're working on a region of 3.5 to 4 million square kilometers. So just to have also a little information here in terms of, we're not looking to specific evidence of a pre-Columbian civilizations, but we were able to identify some structures there that I'm sure that Eduardo is going to explore this very deeply in the next talk. But the LiDAR allowed us to identify those sort of informations, looking not only on the transect itself, but also on the extrapolation that we did with the data with a very fine surface model. So just as a closing remark, the data supported production of this new forest, Amazon forest biomass, including the uncertainty associated to that. The strength of this data allowed us also to have a box, which is a suggestion for methodology on the IPCC guidelines for greenhouse gas emissions inventory that was published in 2019. So there's a huge avenue for explorers still interested in science and new science in the region. The data that is available is basic. It goes from the full waveform from the LiDAR clouds to discrete data from all clouds as well. Normalized points on those clouds, and the metrics calculate on the resolution of that small as 50 by 50, and all the satellite data used for the biomass map. So I just would like to acknowledge the huge amount of people that helped on this. We did a lot of consulting, a lot of connection to other institutions and colleagues. And with that, I would like to thank you very much for your attention. And I would now pass the word to my colleague, Eduardo Neves, for the next talk. Thank you very much.
Well, hello, everybody. It's a pleasure to be here as well with my colleague, Jean Ometo, in the Earth Archive conference. I'd like to thank Chris Fisher and the organizers for having me here. My name is Eduardo Neves. I'm an archaeologist based in Brazil, in São Paulo, Brazil, at the University of São Paulo. And I've been doing archaeological field work in the Brazilian Amazon for over 30 years. I started as a student, still as an undergrad, and have been working there since then. I've worked in different parts of the Amazon. I did my PhD here in northwestern Amazon, near the border of Brazil and Colombia. I've worked for many years in the central Amazon area of Brazil, near the city of Manaus. And right now I'm working in the area in southwestern Amazon, in areas of Acre and Rondônia states in Brazil, and also with my colleague Carla Jaimes Bittencourt in the Bolivian Amazon. As Jean's presentation just showed us right now, the Amazon is a huge area. I'd just like to mention that almost 20% of the above ground fresh water of the world gets into the Atlantic Ocean by the mouth of the Amazon. That's lots of biodiversity, as we know, but I'll talk a little bit about the archaeology, not so much about LIDAR, but things that we could do with LIDAR if we apply it to Amazonian archaeology. What we also know is that the Amazon is today a place, it's the last remaining place of the world where we have a large concentration of isolated indigenous groups. This map here shows us the points in white where we have evidence of groups that the indigenous people live without regular contacts with the national societies. And you see by looking at this map that many of those places are located near the orange areas, which are the areas where deforestation has been acting and hitting very hard the Amazon. We lost 20% of the Amazon in the last 40 years due to deforestation. And these images, like, everybody saw them a few years ago. These are the Mashco Piro Indians who live in the border between Acre, Brazil and Peru. So these things, are happening all the time now across the Amazon. And one of the drivers for deforestation and one of the drivers for in the encroachment of isolated indigenous people in general and their traditional lifestyles is the advance of agriculture, of soybean farming, of cattle ranching, and of illegal logging as well. I've taken this picture a few years ago near the area where I work in southwestern Amazon. But if you look at the archaeology of the Amazon, for many years people used to think that the Amazon was this backwards place in the deep history of South America, that there'll be centers of innovation high up in the Andes, and places such as the Amazon will be marginal, peripheral areas in this deep history. But we know today that this is not a clear picture. For instance, it's established today that the Amazon was an independent center of plant domestication in the world. If you look at this map here, we're going to see some of the known centers of independent plant domestication in the Near East, in Mesoamerica, and in the Amazon we have two of them at least. One of them is here in southwestern Amazon. We also know that this map here is in Portuguese, but some of very important plants that we use across the world today, like peanuts, like manioc, now the acai palm, which is a super berry coming from the Amazon, cacao. These are all plants which were domesticated or cultivated early in the Amazon. So we have a very deep history of human occupation going back to at least 12,000 years. And from the beginning, indigenous people were changing and managing, transforming nature, for instance, through the domestication of plants and also of the landscape. For instance, the Brazil nut, which is a very important plant. It's a big tree. It can live for up to 400 or 500 years. It's planted on stands. And we know it's a cash crop today for countries such as Brazil and Bolivia. We know by looking at the archaeological record that it's being already consumed by indigenous people for 11,000 years. So we're dealing here in the Amazon with very ancient and very resilient productive strategies, which have really have traveled throughout time through indigenous people, and are really threatened today by deforestation. These are some of the products that we have. People still eat this thing for the breakfast today across the Amazon, like root crops, papaya, maniocs. Some of those plants have been cultivated for thousands of years. Other examples here, we have cacao here, cashews, the acai palm, vine. Again, other examples of these diversified and important productive strategies. So, as an archaeologist, I think that archaeology has a very important role in telling us how this process was, I'm going to use the expression here, landscape domestication unfolded over the millennium. If you look at the archaeological record, at the archaeological sites, and by applying contemporary techniques of archaeological investigation, looking at botanical remains, fauna remains, analyzing soil remains as well as the ceramics and lithic stone materials produced by these people, we can understand how this process of landscape domestication unfolded over the millennium. And I'd like to talk about two areas here where I've been working that have a very strong potential for application for Earth Archive. I'm going to go back to the previous slide. This one here is area number one, which is located at Acre State in Brazil, not far from the border with Bolivia and Peru. I'm going to show some images that my friend Jean has already showed in his presentation. Not the same images, but the same kinds of archaeological sites. This area has been hit very hard by deforestation in the last 40 years. Everything that you see here in light green are areas cleared by basically cattle farming here, and everything that you see in dark green here are areas still covered by forest. This, by the way, is Bolivia here, and this is Brazil. This is another map that can show us, this context here. We see there's much more deforestation on the Brazilian side than on the Bolivian side. What happened in the last years is that because of the expansion of cattle farming and of agriculture, some of these areas were cleared. And as a consequence, archaeological sites began to be identified. If you look at this map here, we have hundreds of points. These dark dots here, these black points, they correspond to archaeological sites that have been identified in the last 40 years or so in the Acre area or also in southern Amazonas state. Here you can have a general idea of the location of this area within the Amazon. And the sites which have been recovered are really identified, are really amazing. These are geometric structures, earthworks. They can be round in shape, also square in shape. The late archaeologist Denise Chan did a wonderful job mapping and excavating together with Alceu Hanzi, a Brazilian paleontologist which was based in Acre State. They did a wonderful job mapping and excavating some of those sites, and we know that they began to be formed at least 2,500 years ago. These are some these are other examples of those sites. You can see that some of them, we have roads coming out of them, double moats around square structures. And again, it's important to make it clear that these areas are open today by pasture. But these were covered by forest until at least the 1970s. And we've been excavating some of those sites. And the results that we've been getting, this is not LiDAR mapping. This is just like a low-tech drone mapping that we did together with colleagues from the Kew Gardens in the UK, and Sauna Salanuoma from the University of Helsinki in Finland. But what we did, we excavated some of those sites. You can see here their arrangement. These are ring villages, ancient ring villages with mounds located around central plazas. There's one here, there's another here, another here. And if you look at it, you can see very well how we have roads coming out of those sites in a kind of sun-like shaped, in a radial pattern. And we were able to connect, if you look at this map here, just using Google Earth, we're able to, and the drones, we were able to connect those roads, realizing that there was a network of archaeological sites connected by these ancient roads. We radiocarbon dated those contexts, and we know that these roads date at least to around 1,000 years ago. So at least for 1,000 years, I think it's much older, to be honest, but at least for 1,000 years, we know that people were building those mounds and creating those roads, connecting them. If you imagine if we expand this area, this work to forested areas, I imagine that we're going to find many more sites and roads such as this. This is a publication by José Iriarte's group. José Iriarte is an archaeologist also working in this area, doing a very nice work. And these are some of the LiDAR mapping that José has presented. And you can see here as well the ring villages. You can see that the circular pattern here and the roads connecting these villages. My colleague Jennifer Watling, who's an archaeobotanist based here in São Paulo, she was actually José's PhD student in the UK, did a wonderful job for her PhD in this area because she was able, she opened up excavation areas away from the archaeological sites, not inside the archaeological sites. She wanted to get proxies that could tell her how was the landscape in these areas during the occupation of the sites. And she came out with a wonderful result. She was able to show that during the occupation of the sites, there was a process of replacement of bamboo-covered forests by palm-covered forests. In other words, these people were transforming one kind of forest into another kind of forest. And what we're doing today in Brazil or in the Amazon, we're destroying, replacing forests by pasture and destroying the rainforests and their people's lifestyles. Also, recent mapping done in other parts of the Amazon shows that this pattern that we see here in Acre, there's a larger concentration, prevails across the southern rim of the Amazon. I suspect that if we begin to flying LiDAR within the Amazon, inside the Amazon, we're going to find these things all over the place. And we actually have some preliminary evidence that shows. So, again, we have to take into account the impact of these people living there into the shaping of the contemporary Amazon. That's just an example of the sites and the excavations. And here you can see how deforestation in yellow has been advancing very strongly and how some of those sites today are being, actually people are planting soybeans all the way around those places. Just have a very short Final example, another place in the Amazon, also in southwestern Amazon, the Guaporé floodplains, where we've been working with my colleague Francisco Pugliese and Carlos Zimpel since 2013. We've been excavating a fluvial shell mound there, an artificial island. If you look at this place here, this is an artificial island located at a transitional zone between a flooded savanna and an evergreen tropical rainforest towards the north. And this place here, during the rainy season, becomes an island. It looks like a natural place, but it's actually an artificial place. And our excavations, this is a stratigraphic profile of the site, so you can see the strata and the layers that compose this island. We know that the base of this island was occupied 6,000 years ago. And if you look at this image here to the right, this yellow stratum here, there's an artificial stratum composed of clay brought from far away to establish a base for the construction of the island. So we have evidence of nature, management of nature and the constructions of artificial structures in this place going back to at least 6,000 years ago. There are many more places like this to be found in this part of southwestern Amazon. So I think, just very briefly, these were just two examples to give you an idea. There's a huge potential for LiDAR in the Amazon. And I think the major contribution that LiDAR can do is to show how indigenous people have transformed Amazonian landscapes and how their lifestyles today have to be preserved and respected, because they were able to live in the Amazon for thousands of years without destroying it. In the last 40 years, we just did away with 20% of this wonderful basin. Thank you very much.